Hi everyone, welcome. Let's dive into a super relevant topic, especially for those interested in civil construction and residential engineering. Disaster-resistant homes in the United States. Have you ever wondered how the foundation is built to withstand hurricanes and earthquakes? Today, we're going to explore all the details. And if you like this type of content, go ahead and subscribe to the channel and activate the bell so you don't miss anything.
It's great to be here. It's funny, when we talk about American homes, I think most people assume it's pretty monolithic.
Right, that a house is just a house no matter where you are.
Exactly, whether it's in Seattle or Miami. But looking at the sources we pulled for today, that's just fundamentally not true.
It really isn't. It's more like a tale of two completely different engineering philosophies. It's almost like two different countries. We're looking at the West Coast, so California versus the Midwest, and we're zeroing in on Chicago.
And it's so distinct. On one side, you have this philosophy that's all about flexibility, speed, and what I'd almost call calculated impermanence. That's California.
Okay, calculated impermanence. I like that.
And then on the other side, in Chicago, it's all about fortification, thermal mass, legacy.
And what really stood out to me in the research is that this isn't just about aesthetics. It's not that Californians like that rustic look and Chicagoans want some heavy industrial vibe.
No, not at all.
It's a really complex equation. We're talking supply chains, tax codes, and even what kind of disaster you're building for, fire versus wind.
Right. We have to look at the actual bones of these cities. If you drive through a California suburb, the optical illusion is pretty strong.
What do you mean by that?
Well, you might see stucco, you might see something that looks a lot like brick, but if you look at the actual construction data, the vast majority of that is just wood framing.
So it's a veneer. The real structure is timber, just 2x4s and plywood.
Precisely. Whereas in Chicago, the mantra, and this is a direct quote from one of our sources, is you can't beat the brick.
And they mean it, right? Not just a brick look.
No, they often mean structural masonry, or at least a full brick envelope that's actually doing a job against the elements.
Okay, so let's unpack California first.
Right.
Because to an outsider, it does seem a little counterintuitive. This is the most high-tech state in the country, but they're building their houses out of, well, sticks. Why wood?
The biggest driver is the most basic rule of engineering economics. What's available.
Right.
You just have to look at the geography. The Pacific Northwest and Northern California have these massive softwood timber reserves.
Right, so the supply chain is hyper-local. You're not shipping steel from Pennsylvania or anything. You're just trucking lumber from a few hundred miles away.
Exactly. The internal market for lumber out west is incredibly efficient, but, beyond just the material cost, we really have to talk about labor.
This was the data point that really jumped out at me, the timeline. The sources say a standard wood-framed house in California takes, 12 to 14 weeks?
Yeah, from breaking ground to getting the keys, which is just incredibly fast.
I mean, that's nothing.
Think about it. With wood, you frame it, you sheath it, you can run all your electrical and plumbing through the open stud bays. It's like a rapid assembly line.
As opposed to concrete or masonry.
Yeah, where you have curing times. You can't just pour a foundation and start building on it the next day. You have to wait for it to reach a certain strength.
And you need different workers.
Right.
More specialized.
A different tier of skilled labor, for sure. A framer and a mason have different skills, different hourly rates. In a market like California's, where demand is through the roof, speed is everything.
If a developer can turn over a project in 3 months instead of 6.
That's a massive lever on their return on investment. Huge.
There was one other variable, though, that really caught me off guard. It wasn't just materials or labor, it was taxes.
Yes. This is a massive factor that almost always gets overlooked. It comes down to how the state assesses what they call permanent improvements.
And a concrete structure is seen as more permanent.
Exactly. In a lot of places, a concrete or masonry building is classified as a higher value asset right from the start, compared to a timber frame.
So you're basically penalized for building something more durable. Build a bunker, you get a higher property tax bill.
That's the long and short of it. If you build with wood, you're using what's considered a depreciable asset, which can lower your initial tax burden. So all the incentives line up. The wood is local and cheap, the labor is fast, and the tax man is happier.
It creates this self-reinforcing loop.
It really does.
And then there's the sociological angle the research mentioned, this idea of transience.
This is so fascinating. California has one of the highest mobility rates in the country. People move for tech jobs, for lifestyle.
And the housing stock kind of reflects that.
It does. A wooden house is flexible. If you buy a lot with some little 1950s wood bungalow on it, you can bulldoze that thing in a weekend.
Right, versus a concrete house.
Which would require heavy demolition, significant costs.
Yeah.
So the wood house it fits the whole ethos of a population that's constantly reinventing itself.
We should probably mention earthquakes too. Even though our sources are heavy on fire, wood does have that flexibility, that ductility.
That's a fair point. Absolutely. Wood has a great strength-to-weight ratio, and it performs pretty well in seismic events because it flexes instead of shattering like, say, unreinforced masonry would.
But
But that benefit comes with a terrifying trade-off.
the fire load.
Yeah. You just can't talk about California construction without talking about wildfires.
The numbers from the Camp Fire in Butte County are they're harrowing. November 8th, 2018, over 18,000 structures gone.
And when you look at the analysis of those events, the question just hangs in the air. Would the material have made a difference?
Which brings us to fire ratings. And I want to get technical here for a second because the difference isn't just wood burns, it's about the actual ASTM ratings.
It is. And when you look at the numbers, the gap is, it's terrifying. A standard stick-built wall, with drywall on it, might get you a 1-hour rating.
60 minutes.
60 minutes before structural failure under a standard fire load.
Which, in a firestorm like the Camp Fire, is literally the blink of an eye. Those fires were moving faster than people could run, with heat intense enough to melt engine blocks.
Exactly. Now compare that to a standard CMU, a concrete masonry unit.
A cinder block.
Right, even a hollow block, just on its own, gets you a 2-hour rating. But the sources point to the filled CMU spec.
That's where they fill the cells with concrete and rebar.
Yeah, and that pushes the rating to 4 hours. 4. We're not just talking about giving you more time to escape. We're talking about the difference between a house that collapses into ash and a house that can actually act as a fire break.
A 4-hour wall could potentially survive the fire front passing over it.
It could remain standing. So the engineering data is crystal clear. 4 hours versus 1. So why hasn't the insurance industry, with $5.1 billion in losses, forced a change?
That's the billion-dollar question.
It's just the inertia of the entire ecosystem. You have a labor force trained for wood, a supply chain built for wood. To switch to concrete would mean retraining hundreds of thousands of workers and completely retooling the state's logistics.
It's an economic lock-in. So they're basically accepting this catastrophic but low probability risk of fire.
To maintain the day-to-day economic efficiency of wood construction, that's the gamble.
Okay, let's pivot. Let's fly over to Chicago. Because if California is betting on speed and flexibility, Chicago seems to be betting on the exact opposite.
Chicago is a completely different animal. We were looking at insights from a real estate expert there, Ben Lawless, and he says for 9 out of 10 developers, brick isn't just an option, it's the standard.
Keen brick. And it's not just for looks, it's about the physics of a Chicago winter.
Correct. We have to talk about something called thermal mass.
Okay, break that down for us.
So a wood-framed wall relies on insulation, like fiberglass, to stop heat from moving. It has a high R value, but very low mass. Brick and masonry have high thermal mass. That means they can actually absorb, store, and then later release a lot of heat.
It's like a thermal battery.
Perfect analogy. In a Chicago winter, that heavy wall creates a thermal lag. It smooths out the temperature inside against the crazy fluctuations outside. When you've got that sub-zero wind whipping off Lake Michigan, you don't just want insulation, you want a shield.
And he also mentioned longevity, right? The fortress idea.
That's it, exactly. A brick home in Chicago is built with a 100-year life cycle in mind. It just holds up better against the wind, the rain, the snow than wood siding, which can rot or warp over time.
But brick is expensive and it's slow. It's skilled labor, laying one brick at a time. So what happens if you're in that market but you can't afford the fortress?
And that's where you see the alternatives come in.
Yeah.
And they all have pretty significant compromises.
The most common one seems to be vinyl siding.
Which is really just a plastic envelope for your house. Thin sheets of PVC.
On the plus side, low maintenance, no painting.
True, but it's flimsy. And the big problem is that it fades from the sun. And once that color is gone, you can't repaint it. You have to literally strip the whole house and put new siding on. It's a disposable solution.
Then you have hardy board, which feels like a middle ground.
Fiber cement siding. It's a composite material, sand, cement, cellulose fibers. And it's actually fantastic when it comes to fire resistance and pests. termites can't eat it.
But it's still just a panel, not a structural wall.
Right, it's a cladding. So you can still have issues at the joints, gaps where wind-driven rain can get in. It doesn't give you that solid, monolithic protection you get from brick.
Now, we have to spend a minute on the warning that was buried in the Chicago research, because it's like a real public service announcement for anyone buying a home there. The split-face block.
Yes. This is such a critical thing for people to understand. We talked about CMU, cinder blocks being strong, but split face is a very specific aesthetic type of block.
It's the one with the rough stone-like texture on the front, right? You see it all over new condos.
Yes, exactly. It creates this rugged, textured look. And developers loved it because it gives the impression of expensive stone, but it installs as cheaply as a regular cinder block.
But the physics of it are an absolute nightmare for a cold climate.
It basically acts like a sponge. The process they use to create that rough texture opens up all the pores in the concrete.
So it just soaks up water.
It wicks moisture right into the face of the block when it's raining or snowing.
And then night comes, the temperature plummets below freezing.
And that water turns to ice. And it expands by about 9%. And it literally pushes the face of the block off from the inside. It's called spalling.
So you have these buildings that look tough, but the facade is just crumbling away, and there's probably mold growing on the drywall inside.
It's a catastrophic building envelope failure that's just masquerading as a design choice. And the source warns this material is basically not used for residential living spaces anymore because of the liability, but you still see it everywhere on the market.
A classic case of aesthetics and cheapness overriding the basic engineering reality of the climate.
And that, I think, really brings this whole deep dive together.
It's all about context.
There's no perfect material. Wood isn't bad, and brick isn't good in a vacuum.
Right. Wood is actually the perfect solution for California's economy and its seismic needs, as long as you're willing to accept the fire risk.
And brick is the perfect solution for Chicago's brutal climate and that desire for permanence, as long as you can afford it.
It's about matching the material to the specific stresses of the location. What works in LA would be a total disaster in Chicago, and the other way around.
Totally. You wouldn't want an unreinforced brick house in an earthquake zone. It would just crumble. And you don't want a light wood frame trying to hold in heat during a polar vortex.
So here's a thought for everyone listening. We want you to interact with your own environment a little differently after today. The next time you're out walking, tap on the walls of houses.
Literally, just give it a knock.
Does it sound hollow? Is it just a facade hiding that wooden frame? Or does it feel solid? And if you're in the Midwest and you see that rugged split-face block,
Look really closely at the base. Look for that crumbling, that spalling. Check for signs of water damage. Understand the engineering that's hiding right under the surface.
it's amazing how much is hidden in plain sight.
It really is.
Well, that's it for a deep dive into the bones of American homes. We hope this gives you a whole new lens to look at the streets you live on.
Always a pleasure digging into the details.
Thanks for listening, everyone. We'll catch you on the next deep dive.